So in this question, we will solve the simple derivative questions, derivative questions. And this is like from the exam paper of 2025. And let's do the first part, or maybe let's start from the fourth part. Let's start from the fourth part. Now f of x equals to x plus one to the raised power of 1 upon 3 or cubic root, right? So it's a function within a function. So I'll apply and how it is a function within a function. I have x plus one, and then this is like this can be considered as a one function, and then I have an outer function. So I can apply here the chain, right? So let's take the derivative of the outer function, and then you will take the derivative of the inner function. So my outer function is f of x equals to x plus one, and I can write down the power in this format, 1 upon 3. So a cubic root means the power is 1 upon 3, and square root means the power is equals to 1 upon 2. So now let's start taking the derivative and apply the what I refer as a chain rule. And if now this is your outer function, take the derivative of the outer function and apply the power. So 1 upon 3 into x plus 1 to the raised power 1, 1 upon 3 minus 1. So this is the power rule and multiplied by the the derivative of the inner function. And now the inner function is x plus 1. So the derivative of the inner function would be just 1 because the derivative of x would be 1 and the derivative of the constant is always 0. So you will get 1. So 1 upon 3 x plus 1 to the raised power. Now 1 upon 3 minus 1. 1 upon 3 minus 1 would be 3, 1 minus 7. Is that right? No, wait, minus 3, sorry. Then it's 3. So you would get minus 2 upon 3 as the power. Minus 2 upon 3. So x plus 1 to the raised power 2 upon 3. So you can write it down in this way. I applied another rule over here. So if you have a to the raised power minus x, you can write it down as a to the raised power x. So this is exactly what I did over here. So this is your answer for this question. So we solved the fourth part using the chain. And now let's do the third part. Third part is quite simple. Okay. Third part is so f of x equals to 2x upon 3x. 2x upon 3x. So you can like simply write it down 2 upon 3 to the whole power of x. Of course, like you can write it down in this way. And then you can basically take a hint from the statement and you can apply them over here. And what can you do here? How can we do this? So now if you take the derivative of this, and basically you'll apply this logarithm and you see here, if y equals to a to the raised power x, now your a is basically the constant. So 2 upon 3 is your a and x is in the power. X is something that is our of concern. That is the independent variable that we will take the derivative with respect to. So x is the variable that we're taking the derivative with respect to. So when we have something similar to this, we apply this rule. So we apply this rule. So let's apply this rule. If I start taking the derivative, I'll get um I'll get 2 upon 3 to the raised power x ln of a ln of a 2 upon 3. So this is my answer. Simple. This is like just one step, answer question. Now let's do the second part. Second part is f of x equals to e to the raised power x into x minus x. So here you see two functions are getting multiplied with each other. You will apply the product rule. So let's say this is your a and this is your b. Product rule is a derivative b as it is plus a as it is b derivative, the derivative of b. Now let's apply this product rule on the second part. And if you start taking the derivative of this function, if you take the derivative of the e of x, you'll get the e of x as it is. I told you, e to the raised power of any function, you'll still get the same answer. It returns the same function. And b as it is. Now your b function is x minus 1. In the second term, the a would be as it is, and the derivative of the b part. And the derivative would be 1, just 1. So you will get this as your answer. Now you can take the e of x common in these two terms. So you'll get x minus 1 plus 1. So e to the raised power x into x. Okay, x. So this is this is just simplification. Simplification. Your derivation has been done at this point. The second step, this step was actually the simplification of my answer. So that depends if you want to do it or not, but it's good to do it. It's always good to perform, to write your answer in its most simplest form. Now let's do the first part. F of x equals to 3x squared plus x under. Now this is like simple power rule. You just need to apply the simple power rule. The power rule would be 6x, right? Plus x 1 upon 2, 1 upon 2 minus 1. I hope like this makes sense to you because x square, x under root means x to the raised power of 1 upon 2. Now just simply apply the power rule over here. 1 upon 2 x, 1 upon 2 minus 1. This is the simple power rule that we study. Plus 1 upon 2 x to the raised power half minus 1 would give you minus half. So again, I told you, write your answer in its simplest format. So you will get 1 upon 2 x under root. Or you can also write it down in this way. That's the same thing. Both are the same answer, right? So I hope this makes sense to you. Now let's move to another. Yes, this one. Yes, let's solve the D part from from the exam paper of 2024. The first part. I'm starting from the first part, this one, this time. F of x equals to 4x cubed plus 7x plus x under root. Now, simply apply the power rule on all of these terms. So if I take the derivative, so I'll get 12x squared plus 7 plus um, x to the raised power half. So if I apply the power rule on this, minus half, so I would get 1 upon 2 under root x. So that would be, so you can rearrange the answer, 12x squared plus 1 upon 2 under root x plus 7. So that is the answer for the first term, for the first question. Now let's solve the second part. And by just looking at the question, I tell you that this is a problem of product rule. So I got two terms which involve x getting multiplied with each other. So x is my a and ln x minus 1 is my b. So according to the product rule, the derivative of the a, b as it is, plus a as it is, the derivative of the b, right? So let's start taking derivative. If I take the derivative of my first part, which is just x, so the derivative of x would be 1. So 1 into ln. So I was solving my second part. I was solving my second part, and I was using the product rule over here. So I took the derivative of my first part, x, which would be 1, and b as it is. And then in the next term, my a would be as it is, but this time around, I'll take the derivative of the b part. And the derivative of the ln x would be what? 1 upon x, simple. And the derivative of minus 1 would be 0. So x into 1 upon x. So I would get ln x minus 1, and this x will get cancelled out with this one, plus 1. So your answer would be ln x, because this minus 1 would cancel out with this one. And at the end, you will just left with the f bar. The derivative would be ln x just. Now, let's focus on the third part. And this is like quite important one, because in the third part, I can see that we would be applying the quotient rule. F of x equals to x squared minus 1, x minus 1. Actually, you don't need to apply the quotient rule. Why? Because see, if you look at the numerator is x squared minus 1, right? And a squared minus b squared equals to a plus b, a minus b, right? So this is one of the identities, if you could recall. So if I look at my numerator, this numerator is basically x squared minus 1 whole square. I can write it down in this way. So that means I can apply this identity. So that would become x plus 1, x minus 1. So in my numerator, I can actually f of x would be equals to x plus 1, x minus 1 divided by x minus 1. So this x minus 1 would get cancelled out with this one, and my f of x would only be x plus 1, right? So if I take the derivative of this function, that would just be 1. That's it. That's the answer, right? And then you have the fourth part. The fourth part is f of x equals to 1 upon x plus 1 whole under x plus 1 under. So that's again like f of x equals to 1. And here you don't need to apply the quotient rule. You will not apply the quotient rule. Why? Because in the numerator, you do not have any function of x, right? That's why I'm not going to apply the quotient rule on the fourth part. Rather, I'll look for some other, and I can write it down my function in this way, and my f of x I can also write it down this way. So if my 1 upon a to the raised power is minus x, I can write it down. This is equals to a to the raised power of x in this way. I can take the reciprocal, but then I'll turn the negative power into positive, right? And vice versa. If it's a negative power, it'll get positive, and if it's a positive power, it'll get negative. Now I can simply apply the power rule. If I apply the power rule, the power would be will become the coefficient, and so I would be applying the chain rule technically. So x plus 1, and then minus half minus 1 into the derivative of the inner function. My inner function is x plus 1. So the derivative of the inner function would be just 1. Be very careful of this chain rule. Minus half minus 1 equals to 2. This would be the answer. So minus 3.2. So this is the answer for the first part. I hope this helps you for your exam and all the best. All the best.